SwayamPrabha. Digital India. Educated India.
Good morning everybody and welcome again to our course on Introduction to Micromechanical Machining, but this class is related to demonstration of profile measurement of different type of micro components. Today we are going to discuss one of the techniques by which you can do measurement of a 3D components, and this instrument is called the interferometric based measurement. So, initially we have covered in our lectures that there are 2D measurement also we can perform and 3D measurement can be also performed, but 3D measurements are more realistic in nature because mostly the surfaces are exist in 3D nature. So, we will see the which way these instruments give you the measurement in terms of a 3D dimension, because what is the objective? Once you complete your machining by a micromechanical machining, we have to find out the what are the different dimension it has produced, and we have to cross check with the design part there whether there is deviation between the desired measurement and the what measurement you have received from the machine component. So, these particular instruments will give you all the idea about the depth wise as well as width and the length wise depending on which type of objective lens you are using. So, this is a non-contact measurement. So, your surface will not be touched by any type of measurement probe or measurement system, but it is a light based measurement. So, light will be reflected onto the component and then it will reflect and it will be captured by one other standard reference, and then it will create a interferometric fringes. So, fringe creation is more important, and when it reflects, that means the reflectivity also play very important role here, because if the surface is very non-reflective, then getting fringes is very difficult. So, let us first see that which way this instrument is working. So, if you see here in this instrument, here what things are there? There are two different objective lenses are there. So, this particular objective lens has 5x magnification. So, whatever component you are putting at the bottom, that will be magnified by the 5x or the 5 optical zoom. There is another lens which is not used right now, that has a 20x magnification. So, 20x, that means your objective or the object will be magnified by 20 times. So, here how you can select these two things, that suppose your surface has a very big range of the measurement, that means suppose it is in 1 millimeter or 5 millimeters and you want to capture everything in a single measurement. So, it is better to go with the 5x, because 5x has a measurement area of a 3 millimeter by 3 millimeter, and if you have a surface or the features which is very small and you want to capture a small detail of those measurement, then you can use a 20x. So, we have two different magnification lenses, but there are many ranges. You can start with the 2x magnification to 100x magnification depending on your requirement. So, here what we have done, that from the fabricated micro tool we have cut one micro channel with a depth around 300 micron, and the channel width we will measure by this particular instrument. So, once you complete the measurement, you will understand that it is very difficult to see by naked eye what are the dimensions are fabricated. So, to get those things, this is the 3D measurement. There is another one, it is called scanning electron microscopy, by which you can get the measurement in terms of a 3D with a higher depth of focus. So, let us go into the machine screen. Here what we are seeing here, so this is what you are looking at here, this is the micro channel which is fabricated on a PMM material. So, it is one type of polymer material which is more widely used for the microfluidic studies, and this is the size of that thing. So, here first objective is to create the fringes, so that your machine can understand that where are the different surfaces are located. So, first thing we have to find out that first you have to see that, because if your surface is very large, you have to locate this particular location. So, by this way, by moving of this particular screen, you can actually get the exact location. So, this is the location, you can get this thing here, and then we have to focus at the different layer, because once you get a micro channel, there are two surfaces, one is on the top surface and another one is the bottom. So, your machine should actually get both the surfaces captured. So, first we will capture the top surface and then we will go to the down one. So now if you see it, our microscope head is going gradually down and it will create a fringes onto the top surface. So we are going very, very slowly so that we can get all the things very precisely. So these are the fringes which are created on the top surface. Now these fringes, whatever you are getting, that means your surface is captured by the microscope reference surface. So this is the top surface right now, what we are getting. So this is the top surface. So we have to create a benchmark for the top surface measurement, and then we are going gradually down to get the bottom surface. Since the bottom surface is very narrow, you will find a very small, less amount of fringes, but that is enough to capture the required details. So now it has started. If you see that internal part, then you will get the information here. So small amount of fringes are already captured by that. You can see that now these are the fringes. So these things are created, and let us start the measurement. So now your instrument is starting from the top surface, and it gradually will go down and captured all the details. Now it is measuring fringes here, you can see that. So now it is almost completed. Now this is the new software. That means earlier software was the machine software, and this software is the analysis software. So whatever things you are getting, that is transferred to this software so that you can do different type of measurement here. So this is the surface what we are getting here. And here now we can convert this thing into the 3D view. So now you can see that this is the channel which was fabricated by that end mill cutter. So now here whatever information we are getting, now we have to see that what are the dimensions of this micro channel width wise and the length wise. So what we need, that we need a cross section of this. So here what we can do, that we operate this thing and then do the extend the profile. So by this way you can see that we can get the different type of profile here. You can cut down from here to here, and this will be the now let us take this thing, and so this is the cross section of the profile. Now if you want to do measurement of different heights and all the things, you can select that also, that you want to do some measurement there. So here you can see that what is the height is here. So it is measuring from here to here, and you can do that this maximum depth is 35 micron is the depth here. And if you want to do measurement of other measurement, so this is the distance measurement, then you can do one thing, that you create one reference surface here. So this is our reference surface and this is the under bottom surface. So this is telling you the height difference. So now whatever is height from here to here, that is the difference is around 30 micron. That is also what we are getting here. So this is the point wise, but here it is the area wise. So it is getting the average area of this part and the average area of this, and then it will give you the depth here. If you want to measure the width of this channel, then what you can do, you just start from here and move this particular thing to this location here. Then let us see. This is the step. Horizontal distance here. So here what we are getting here, so this is what it is showing. What, who has changed these things? Now both the things are coming. So from these particular graphs you can see that the channel width is almost 300 micron if you start from here, 0.3 millimeter. So it is the width measurement from here to here, and it is showing height measurement, but height is not important right now for us. Then what we can do, that we put one extra bar here, and that extra bar can be useful for measurement of that also. Right, so this is the extra cursor. So now what we can do, we can add this thing here. So at that time it will tell you the difference between, this is the 0 and 1 difference is showing here, and this is for measurement of the width. And if you see the measurement of 2 and 3, then you are getting the height difference. It is a 30 micron is the height difference. So by that way you can do measurement of different parameters. This is one of the thing. Suppose you want to measure the surface roughness on this component, that is also possible. But right now it will not show you some clear idea, because it is right now very deep inside the surface, but still let us try, we can get something from there. So for that what we have to do, we have to extract some area out of it. Right? So this is the something we want to extract from the surface. Then we can get some small thing here. So this is going inside the surface. So this is what we are getting here. and this is the surface, and suppose you want to do measurement of different parameters, then what you can do, this is the parameter table. So here it will give you the area roughness. So area roughness is SA, that is called area roughness. If it is RA, that is a line roughness. It is showing 2.395 is the micron, that much micron is the surface roughness. And suppose you want to do measurement inside the area, that means along the line completely, then what we can do, that we select this particular parameter, then operate and select the extract the profile. Then what we will do, that let us put one full line starting from the end. So this is the roughness line of the internal surface, that is the bottom surface. So this is the part. If you select this thing and then again go to the study and do the parameters, so now it is giving you all the value related to the line roughness. So here the surface roughness is 1.9 micron, which is showing here in this case. So you can do different kind of things here, the measurement of area, measurement of length, width, surface roughness measurement, all the things are possible by this instrument. So this is all about the measurement of a micro features by a 3D measurement using a non-contact methods. Thank you very much.